Alright, hello. Hi everybody, welcome back. Okay, hello. Alright, welcome back to the video. And it is me, Miss Dorga, ready to help you pass this test. Hopefully you are going to watch it, and hopefully it will help you prepare for the test tomorrow. Part 1 of this video is only going to have the things that you will see on Friday. Part 2 of the video will have all of the things that you will see on Monday. Okay? So I'm splitting them into 2. Alright, tomorrow you're going to see 3 word problems and 2 inequality word problems. So let's get started with the word problems. Okay, first question, I changed the wording a little bit. And just so that you could see your name and recognize the name of people that I picked. So for the first question, it said Ronnie, but I changed it to Zach and Ryan. So Zach and Ryan kick a soccer ball from 5 feet above the ground. Its initial velocity is 65 feet per second. So you know that you should be using this equation. The VO stands for initial velocity, and this stands for initial height. So your initial velocity here is going to go in for VO, and your initial height is 5 feet above the ground. That's going to go for HO. So your equation should be y equals negative 16t squared plus 65t plus 5. I'd rather you use t and not x, please. Alright, next one says sketch the graph. So in order to sketch the graph, we need some more information. So first thing that we need is the max. So if you can find the max in the calculator, and I don't know if this is going to show the calculator for me. I hope it does. If not, imagine there was a calculator here. And first thing you're going to do is go to your y equals, place this equation in there, and then also put a 0 there because we will need the 0 later. Press graph, and you'll notice that you can't see the whole graph. That's when you change the window. So we're going to change the window. The minimums are always going to be 0, always. So 0 here, 0 here. This can stay at 10, which is the x max. But what we really need to do is change the y max. That's how high it goes. So right now, what we do is usually look at the number that's the biggest. And since 65 is the biggest number that we have here, we're going to use the 65, and we'll make it about 70. Now when you press graph, you should see that you have the whole graph, but there's some of it that's missing up here. So, because there's some missing up there, I'm going to change my window back and make it 75. So now I can see the entire graph. So the first thing I'm going to do is find my vertex, which is what we call the maximum in your calculator. So it's second trace, number 4, the right, we should be left bound. So the left bound will be somewhere up here on the left hand side. See the blinker and put it to the left. Press enter. Then you want to press the right. Press enter, and press enter again for the guess, and that gives us our maximum vertex. So that's 2.031 and 71.015. And you might want to label that as your vertex or your max. Okay, the second thing you want to find is when does it hit the ground. So when it hits the ground, you press second, trace, number 5, And then you want to trace all the way down until you are as close to 0 as possible. Press enter 3 times. And there it is. It's an intersection of the x-axis and your curve at 4.138. We call that our x-intercept. Or when it hits the ground. Alright, the other thing you need is initial height. And that's the starting height. Where did this ball start? It started 5 feet above the ground. So the initial height is at y equals 5. So now that you have this piece of information that you should write down on your test, you're going to label your axis. We're going to do it by ones because our x values are pretty small. And we're going to label this bottom as time. Our height goes as high as 71, so I'm going to number by tens. Now, since it's not going from 0 to 1, we have to draw something called the break, or the squiggly. That represents everything from 0 to 10. And the last thing we're going to do is graph. So we start at 5. Then we go to 2.01 and 71, which is here. Label it. Then we go to 4.138, which is right there. Label that. And connect my 3 dots. Alright, now I can answer the question. So I sketched the graph, I wrote the equation. Now what's the maximum height? That's always the second number. So it's 71.015 feet. When does it hit the ground? That's this number. And that is at seconds. The last thing says, how high is the soccer ball after 3 seconds? And that you can do by pressing second, graph, and go to where x equals 3, and it's at 3 and 56, so 56 feet is how high it is after 3 seconds. Alright, so that is number 1. Alright, let's go now to number 2 because it is a table. And when you have a table, you're going to go to your stat, edit, which is here, and place the numbers into the table. Make sure your L1 and L2 are there or else you won't be able to do it. And if you can't see this, I'm actually just punching numbers into the calculator. Alright, if for some reason, and I'm hoping you can see this calculator, but if you can't, if for some reason you can't, if you have numbers in your calculator, just, if you want to clear it, press clear, enter. Don't press delete. Clear enter will clear up your table. Because if you press delete, you're actually going to delete all of the table. So you would lose your L2 and it becomes L3. So don't do that. Alright, so now what you're going to do is go to Stat, put your right arrow to Calc, and then go down to number 5, which is Quadratic Regression. Press Enter, and you'll see the blinkers waiting for you to press Enter again. So when you do that, you have your A value, which is negative 16, x squared or t squared, and your B value, which is 28x or 28t, and then 5 is your last number, which is your initial height. So we're going to put that into our y equals. And press graph. Now you'll notice it's really short, and that's because this number is 28. So So I'm going to go to my window and make it like 30. And if you see, there's still a lot of room up here. So you can even change it again if you want to get a bigger picture and make that max 25. Notice I really didn't change anything else there. Okay, and there we go. So, of course, the first thing I want to find, well, before I do that, let me write in the equation. So, the equation right here is going to be y equals negative 16t squared plus 28t plus 5. Now we're going to get all the information we need to sketch the graph. So we need the vertex, we need the x-intercept, and that's when it hits the ground. And we need the initial height, which if you look is the last number, which is 5. So it's y equals 5. Alright, so now let's find our vertex. And you just keep pressing the left till you get up there. It doesn't matter how far you go to the left, as long as you're on the left side, and as long as you're on the right side. So our vertex is at 0.875 and 17.25. Okay, next thing we need to see is when does it hit the ground? And that's at 1.913. So now that we have all of this information, we're going to make our graph. So we have to sketch the graph next. Again, time is at the bottom, height is on the side. Since the highest number here is 17.25, I can number these by 2's. And then number these by 1's. And I have a small squiggly. Alright, so I'm going to plot my 3 points. First point is going to be 5 for the initial height. Then it's 0.875 and 17, which goes here. Make sure I label. And then 1.913. That's when it hits the ground. So now I connect these, and I'm done. So the maximum height is right here. That's 17.25 feet. When will the egg hit the ground? That's right here at 1.913 seconds. And then right here is what it is after 1 second. 17 feet. Or you can look at the second graph in your table and look right here at 1, it's 17. Alright, for the next 3 questions, I'm not going to put the calculator up because I think from this point you should be able to see how to put in the calculator. If you're still confused, look at the other 2 if the calculator showed up. Alright, I changed this one. I said Darius threw a snowball at Adrian. Based on the data below, write the equation of the path of the snowball. So once again, you're going to go to your stat edit and put this information into your calculator. when you put this in, you get some pretty big numbers. And the reason why you get some pretty big numbers is because we started out with decimals. And when you start out with decimals, it doesn't give you like a nice, pretty equation. So make sure that you round everything to the nearest thousandth, which is 3 numbers after the decimal. So the first one will be negative 16.361. Not 360, because there's a 6 next to that 0. T squared plus 8.208 T plus 3.965. Now, if you have this as your equation, I will accept that, but I would rather you have it rounded correctly. Alright, so all of my answers are going to be based on this one. So if your answers are a little off, that's because you used this one. Alright, so here's the equation. This was the first bullet. So that's that answer. So now let's find our important information. The first thing I need to find is the vertex. And give me a moment, I'm trying to find it. Alright, the vertex that I got is 0.251 and 4.994. Now, you might have gotten a different one because you used this equation here. So you might have 0.25 and 4.98 or something like that. It'll be a little different if you didn't round properly. Alright, next thing we need to find is the x-intercept when it hits the ground. And that's going to be 0.803. Alright, since our numbers are so small, we are going to number them small. So it's decimal, so I'm going to have my numbers kind of wide. So that's time. And the height doesn't get any higher than 5, so I can just count to 5. Use your max to determine how high your graph should go. So we have height and time. So now when we graph it, our initial point is at 3.965, so it's right about there. And I forgot to write that. Alright, then the next one is 0.21 and 4.99. So 0.21 is not in the middle. It's more closer to 0. And we'll go all the way up here right before 5. And then 0.803 is right before 1. Okay, now we just connect these 3 dots and there's our graph. So if you want full credit for your graph, you better have your x-intercept, your vertex, and your initial height. And then the labels. So when does the snowball hit the ground? At 0.803 seconds. Alright, so if you want full credit, make sure that you have everything labeled. Alright, 2 more word problems. Each year, fireworks are displayed to celebrate the 4th of July. Fireworks are shot from the ground at an initial velocity of 125 feet per second and explode when they hit their maximum height. Write an equation to represent the situation. So, our fireworks are shot from the ground. That means that our initial height is at the ground. When you're at the ground, you don't have a height. So the initial height is going to be 0. We have an initial velocity, so we're using this formula. So your equation is y equals negative 16t squared plus 125t plus 0. Now you don't need to put the plus 0, but I put that there just so you could see what your initial height is. So now we still need to find our information, our max, which is our vertex, our y-intercept, our x-intercept, which is when it hits the ground. And we know that our initial height equals 0. Alright, for this one I will show the calculator for a second. So, when you put it in, negative 16x squared plus 125x plus 0, and you don't need the plus 0, I'm just showing you. When you try to graph it, you can't see it at all, because our window from before had different numbers. So our window should be bigger than 100. So let's do 150 since that's bigger than 125. And if you look, you still can't see it. This is when you just keep playing with different numbers. So we're going to change 150 to 200. Still can't see it. So we're going to try one more change. Let's go to 250. And now we can see it. So sometimes you may have to keep changing your y max until you get it. Alright, let's find our vertex. And it's saying that y is at 225, so it's already up there. I don't have to really move it too much. So I'll go to the left, go to the right, and press enter again. And the vertex is at 3.906 and 244.141, because that's a 6 there. 141. If you put 140, that's fine. So 3.906 and 244.141. Okay, the next thing that we have to find is when it hits the ground. Alright, so just give me a second to find that. And that's 7.813 or 7.812, whichever one you want to pick. I like to round properly. Alright, well, we got some bigger numbers, so our time, we can go to 10. Or 8. And then, as you can see, our max is at 244, so we got to pick some big numbers. So, I think that for our height, it would probably be best if you go by 30s, or by 40s, or even 50s. Okay, so I'm going to start at 30. Alright, I kind of ran out of numbers a little bit, so So maybe I should have went by 40s, but that's okay. Alright, now we're going to plot it. Our initial height here is at 0. And don't forget, guys, your squiggly. Our max goes to 3.906, really close to 4, and all the way up to 244, which is right by 240. And then our hits the ground is at 7.8, which is right before 8. And now you just connect your 3 dots. Alright, so now we can answer the questions. When will the fireworks explode? When is it at its maximum height? So they will explode at 3.906 seconds. When stands for time. How high will the fireworks be after 2 seconds? Go to your second graph, look at number 2, and it's at 186 feet. Alright. Alright, last one, last graph. While walking through the forest, Miss Conway was almost hit by an acorn. A squirrel had thrown it up out of the tree right as Miss Conway walked past. The data below represents the path of the acorn. Alright, once again, we have to go to our stat edit. So go to your stat edit and put these numbers in. First thing you should do is write your equation. And the equation I get is negative 9.982 t squared. And you don't need to have negative 16 here. Plus 12.952 plus 27.012. Alright, just have to move that over a little bit. Alright, so now let's find our maximum. Put this into your y equals. You know you're going to have to change your window. Your highest number is 27, so you might have to change that maximum, that y max, to 27, or something higher than 27. Now, when I use 30 on my graph, it didn't show up. So I'm going to use 35. And 35 did give me a graph. So now I'm going to find my max, and I'm doing this all without showing you. Alright, so our vertex, or you guys know that as the max, is 0.649, comma 31.213. Now your numbers might be different if you didn't round this properly. Alright, next thing I need is when it hits the ground, and that's called the x-intercept. And that's 2.417. Alright, so now I label this as my time. This is my height. My time doesn't go past 2, so I can go by 1s and make big gaps. The highest that my height goes is 31, so I can number these by 5s. Alright, make your squiggly. And then plot your points. Your initial height is at 27. So we're going to go up to 27, which is right here, and make our initial height. Now we're going to go to 0.649, which is past the middle of 0 and 1, and go all the way up to 31. Okay, the next thing we're going to do is 2.417, which is right before the middle of 2 and 3, and plot that. Now make sure that you label. And connect your dots. Alright, how long did it take the acorn to hit the ground? So the acorn started here, then it hit the ground. So it took 2.417 seconds. Now you may be a little off, because you rounded differently, that's fine. How high is the acorn after 2 seconds? It is 13 feet. You can look at that table, or you can press your second graph and go to that table. Your graph in your table might have it rounded to 12.988. If they show the table, you can put that answer there. If not, you're going to have to go by what's in the table in your calculator. Alright, so that ends that section. So now the next section we're going to go into is graphing inequalities. So these 5 were quadratic applications, and you have 3 of these on the test tomorrow. Alright, the next thing is graphing quadratic inequalities. And it's an inequality because of this right here. So the first thing you do is do your quadratic formula. This will be given to you. I'll write it somewhere on the board tomorrow. So you know your A is 5, your B is 4, and your C is -3. So you just plug it in. X equals -b plus or minus square root b squared minus 4ac all over 2a. So now when you work it out, you get 76. Now you want to separate it into 2 answers. -4 plus square root of 76 over 10. And -4 minus square root of 76 over 10. So you can put that in your calculator. And when you put it in the calculator, you get -4 plus square root of 76. And then press enter. Once you get your answer, divide that by 10. And you get an answer of x equals 0.472. If you put 1, that's fine, but it's supposed to be rounded to 472. Now you can do it again in your calculator. -4 minus square root of 76 divided by 10. And you get -1.272. These are called x-intercepts. And these actually are going to go onto the axis. 0.472 is in between 0 and 1. So make a dot there, and then you should label it because you're going to need that label later. -1.272 is in the middle of -1 and -2, and you should also label that because you will need that later. The next thing you need to do is find your vertex. So your vertex is -b over 2a which is negative 4 over 10, which is negative 0.4. Now you're going to take that negative 0.4 and replace it in for x in the original problem. Now you can take the calculator and put it into the calculator. And the calculator gives you negative 3.8. So that is your vertex. So your vertex is going to be negative 0.4 and negative 3.8. And you have to label that. So negative 0.4 is right here in the middle of 0, negative 1, and then count down to 3. 1, 2, 3, and go a little bit past there. You should label that as well for yourself. So now you're going to connect those 3 dots. And there is your graph. So your x-intercepts are right here. These are your x-intercepts. So x equals 0.472 and x equals negative 1.272. These are not intercepts. Don't write those down. Alright, now the solution, it says greater than. So greater than means above x-axis. So you should cover everything that's not above the x-axis and only look here. Now as I go past here, so we're looking at all of the x values here. What are all of these x values? And what are all of these x values? So now, after I leave this number, so after I leave negative 1.272, what is this x value? What is this x value? It keeps going to the left. Since it keeps going to the left, left means less than. So all of the values are going to be less than this number. After I leave 0.472, I keep going to the right. This is going up, but it's also going to the right. Well, right means that the numbers are getting bigger. So all of my numbers are going to be bigger than 0.472. So that means my solution to the problem is going to be x instead of being equal to, it's going to be x is less than 0.472. And instead of being equal to here, it's going to be x is greater than, oops, I have it backwards. X is going to be less than this number, less than that, and greater than that. So look at the direction. You see everything I colored in? This side is on the right, this side is on the left. So anything on the left is less than, anything on the right is greater than. Alright, you will have 2 questions like this. So here's another example. So we're going to use the quadratic formula. A is 15, B is negative 5, and C is negative 11. So x equals negative b, which is 5, plus or minus square root b squared, look at the parentheses, minus 4ac all over 2a. Alright, so now you just need to work out what's underneath that square root. And it's 685. So now, from this point, you can just put it in your calculator. 5 plus square root of 685 over 30. and 5 minus square root of 685 over 30. Alright, so you just put that in your calculator. And the first answer is 1.039. And the next one negative 0.706 or 705. So 1.039 goes after 1. And negative 0.706 goes before negative 1. And you might want to label them because you're going to need them later. Now for the vertex. First you find the axis of symmetry. Negative b over 2a, which is 5 over 2 times 15, which is 5 over 30. And that's equal to 0.167. Now when you're plugging it in, you want to keep it as 5 over 30. Because if you don't keep it as 5 over 30, it's going to round incorrectly. And you want to make sure that you keep it in your calculator as accurate as possible. So use the 5 over 30. And that's a negative 11.417. So that's your vertex. So your vertex is at 0.167 and negative 11.417. Alright, so now we're going to plot that point. So 0.167 is in between 1 and 0. And then negative 11 goes all the way down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, it's all the way down here. So now I'm going to connect. It's going to be a skinny graph. Ooh, that was ugly. Try that again. So this is so long that it went through my answer area. So my intercepts are 1.039 and negative 0.706. Now, since it says less than here, that means we're looking below the x-axis. So you would pretty much cover everything that's not below the x-axis. So we only need these numbers here. So below the x-axis for your means we're only looking at these numbers in here. Well, after we leave this number, the graph goes down, but it also goes to the right. It goes in the right direction. So anytime you're to the right, that's greater than. So that means x is greater than that number. Now after you leave here, it doesn't go back to the right. It actually goes down and to the left. So it's going to the left. Since that's the left, we say less than. So all the x values are less than. So now it would be less than this number and greater than that number. So that's the solution that you're going to write at the bottom. X is greater than negative 0.706 and x is less than 1.039. Okay, these are some pretty big ugly decimals, but hopefully they'll come out okay. Alright, 2 more graphing questions and then this video is done. Alright. Alright, so now you see here that it says x squared minus 5x equals negative 6. It's supposed to be equal to 0. So now we have to move that 6 over and it's equal to 0. So once again we do the quadratic formula. Okay, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we have 5 plus or minus, that becomes 1. So now the square root of 1 is a perfect square. This is perfect square, so we can just find the square root and that's equal to 1. So we have 5 plus 1 over 2. And we have 5 minus 1 over 2. So we can plot those 2 points. Okay, now the next thing we need to do is find our vertex. So it's negative b, which is 5 over 2 times 1, which is 5 over 2, which is 2.5. Now we plug that into the original. And that gives us negative 0.25. So our vertex is 2.5 and negative 0.25. So we can graph that right here in the middle. Very small. So our intercepts are 2 and 3. And our solution means that we're only looking at the less than 0. So that's below. So the below area is not very big at all. It's very small. It's just this little section here. So we're only looking inside this area. Well, after we leave 2, it goes to the right. Right is greater than. And then after we leave 3, it goes to the left. Left is less than. So that means x is going to be less than that number, which is 2, and x is going to be greater than that number, which is 3. So you have to look at the direction that happens after you leave. Now, since there was an equal sign here, I have to put an equal sign in my answer. Alright, a lot of work to show, but it will help. Alright, last question for this video, and then we're done with this video. You should always equal 0. So that means that this is now x squared minus x minus 12 is less than or equal to 0. Now we can work. A is 1, B is negative 1, C is negative 12. So x equals negative b, which is 1, plus or minus square root b squared minus 4a and c all over 2a. Once you work this out, you get 49. 49 is a perfect square, so that actually equals 7. So when you split it up, it's 1 plus 7 over 2. And 1 minus 7 over 2. So those are your two intercepts. X equals 4 and x equals negative 3. Okay, next thing we're going to do is the vertex. So the vertex is going to be negative b, which is 1, over 2a. So that's negative 1 over 2, which winds up being negative 0.5. So now we take the negative 0.5 and put it back into the original. So negative 0.5 squared minus negative 0.5. Oh, it's not negative. Sorry. It's positive. It's positive because the 1 was already negative, and you have to negate that. So it's positive, positive. And then you're going to see what that equals. And that is negative 12.25. So your vertex is at 0.5 and negative 12.25. So we go to 0.5, which is here, and count down to 12. Ooh, almost ran out of room. Okay, so now we're just going to connect our dots. Alright, the next thing that they want you to look for is, since it says greater than 0, we should only be looking above the x-axis, and that's these numbers here. So if we look above the x-axis, that means we only want to know the x values here and here. Well, after I leave negative 3, it goes to the left. So that's less than. After I leave 4, it goes to the right. That's greater than. So that means that my solution is less than negative 3 and greater than 4. So your solution is all based on this. So you have to be able to look. If it's above, you're going to be going in opposite directions. If it's below, you're going to be going into each other. Alright, that ends that video. It's a long video, but I hope you can watch it and then just fast forward through the parts that you may not be too sure of. Okay, good luck.